Welcome to Balancing Chemical Equations. Before you go ahead with this, you should already have looked at naming. So when you see a name like zinc carbonate, you should be able to write ZnCO3 with a bit of working. You don't need to be perfect, but you should have already looked at naming. Otherwise, this would just become too much of a stretch. If that's the case, this periodic table at the top, which has been altered to represent the charges of all ions, so anything in group 1 will always be plus 1 if it's in ion form, in charge form. There's a bit of extra. It's a bit too detailed for now, but silver is always plus 1, zinc's always plus 2. Cadmium's very rare. I guess you should know it's plus 2, although it's very, very rare. And these ones just help. They're just to help you recognize the ones that you're normally working with. All the polyatomic ions should be familiar, except I think acetate's new, and it allows the introduction of acids and bases. You should kind of see that the left hand and the right hand column differ by hydrogens. And there's a relationship between the acids and the bases. And there's a lot going on here. It's not for today to unpack, but there's a lot of patterns. For instance, all these ic endings produce all these eights. So this is the acid, these are the salts. And I could go into a bit of knowledge about acids and bases. This is actually a whole year 12 topic, and perhaps I do that towards the end of this video. We're here today to to write out balanced chemical equations, and part of that is knowing what products to predict. So in chemistry, there's all these types of reactions. So for instance, if an acid reacts with a metal, it's always going to produce a salt and hydrogen gas. There's no exceptions to that. If it reacts, it produces this and that. And then, there's all these other things. So what we're going to start working towards is where we just know the reactants, we know what type of reaction it is, and then we can not only predict the products, we can write their chemical formula and see the ratio that they react. And when you're in year 11, you can start doing some extra stuff on top of that and start working out the ratio that you need to work with in terms of mass for the reaction to come to completion, or work out how much energy you're going to get out of it and all that kind of stuff. So that's what you're working towards. All right, I'm going to go a bit fast in the first couple, and hopefully that gets you into a mood where you can jump off and just do it yourself. And that, if not, there'll be a part 2 with all the answers. All right, so this is a acid. Sorry, this is zinc carbonate. Zinc's a metal. Carbonate's a carbonate. No other way to put it. This is a metal carbonate and reacts with sulfuric acid. So this is a acid plus metal carbonate reaction, and it produces salt plus water plus carbon dioxide. That's already given to you in the word equation. And what I'm telling you is eventually you'll just be able to do questions where they don't give you that. So I should be able to just say zinc carbonate reacts with sulfuric acid, write a full balanced chemical equation. Right. Going to do this quickly. Zinc is 2 plus, it's given to you. 2 minus zinc. The ratio they come together is 1 to 1. I wouldn't stress too much about whether it's a solid or a liquid, although there is some kind of guidelines up here. Zinc carbonate in solid form reacts with sulfuric acid. All acids are always aqueous. It goes to the salt, which is zinc sulfate. Zinc is 2 plus, sulfate's 2 minus, so they're 1 to 1 ratio. All salts are aqueous. Then you got H2O, liquid at room temperature, CO2, gas at room temperature, and this one's a nice easy start because it's all 1 to 1 ratio. It may take you a bit of time to quickly understand that, but I think you'll learn more when it's actually unbalanced. So I'll continue on. Get rid of your working out so people think you're better than what you are. That's how life works. We're on to barium carbonate. Barium is also 2 plus, it's on group 2. Right, carbonate's 2 minus, so it's exactly the same as zinc. We're going to go nitric acid. All that's changed this time is the acid. It's going to make barium nitrate. You didn't need to be told that. And I might pause here. Barium nitrate, I think, is the first time that we're going to encounter writing chemical formula with brackets. So barium is 2 plus, nitrate is minus, and so you got barium, and I need 2 lots of the nitrates, so I go like that to balance out in terms of charges. All salts are aqueous, H2O liquid, CO2 gas, and this is not balanced. I think the thing that stands out the most is the nitrates. I got 2 nitrates on the right hand side and 1 on the left hand side, so I'm going to try to fix that with a 2 there. And lo and behold, it fixes my hydrogens, and this is actually all I need to do to this equation. If you're wondering how quickly, why I can do that so quickly, this has been my worksheet. I've done this probably 50 times before. Oh, that's a bit of an exaggeration, but done this plenty of times before, and practice makes perfect. Right, so lead tells me it's 4 plus, carbonate's 2 minus. The ratio that they come together is 1 to 2, I should say. So 4 plus, 2 minus. And so you go, all right, I need 2 carbonates to match that 4 plus. So you go brackets, I need 2 lots of the carbonate. And then this is going to be a solid. And nitric acid we just dealt with, HNO3 aqueous. And we got lead nitrate. So lead's 4 plus, nitrate's 1 minus. So I need 4 lots of nitrate in aqueous form. All salts are aqueous. I'll keep the same order as the previous questions. CO2 gas, right? And we got carbonates point out as being wrong, and nitrates point out to me, or stick out to me, that they're wrong. So I might just do the same thing I did before. Nitrates are 4. It doesn't really matter where you start, although sometimes there's some good places to start. Nitrate, I got 4 here. I'm going to remedy that and fix the nitrates with 4. That throws out my hydrogen, so I'm going to go straight over to my hydrogens and put a 2 there. That means I got 4 versus 4. Lead's 1, 1, carbon's off. So if I put a 2 there, that actually solves everything. So 1 lead carbonate reacts with 4 nitric acids to produce 1 lead nitrate and 2 waters and 2 carbon dioxides. I think I got time for one more. Oh, I got time for plenty more, sorry. Right, barium chloride reacts. It's gone backwards here. So I've still got my metal carbonate plus acid, but it's just reverse order. What they've done is write the products first and reactants second. Okay, and I guess that's about the only level of trippiness here. We've got barium carbonate, solid. If you're wondering how the hell I, like, as you as a student or a learner, know that it's solid or aqueous, for instance, I've always found this is my best guide. So if I see something paired with a group 1 ion, like sodium, potassium, or lithium, no matter what it's paired with, it will always be aqueous. That also goes for everything in this list. So nitrates, acetates, and ammoniums. If I see anything paired with them, I write aqueous. Okay. I'll go, like, I guess, seeing this barium carbonate, there's nothing on that list that is there. So I kind of, like, I write solid because of that. Like, it gets you there most of the time. HCl, all acids are aqueous. Barium chloride. Barium's group 2. It'll be 2 plus. What I got? Chlorine is -1. So you got +2 and -1. I need 2 chlorines. So barium chloride aqueous plus. It's getting pretty easy at the end here because all I do is keep writing the same products. And really easy fix. Best thing about it is I get a new color. Yellow it is. All right, I think that's 4 metal carbonates in a row. This is metal plus acid goes to salt plus hydrogen gas. This is one of those ones where at first you get it and then later it gets rid of it. Zinc metals. If you're ever writing a metal by itself, it's just you don't write zinc 2. You don't write anything. It's just zinc by itself. Right? And that goes for every single metal. Nitric acid we've encountered